In the Orion Nebula, a well-known stellar nursery 1,500 light-years away, two newly born twin stars were observed. Yet, they don't look like identical twins. They exhibit significant differences. A study published in the June 19th issue of Nature suggests that one of the stars indeed formed significantly earlier than its twin. I'm Lisa Joy-Zagorski from the National Science Foundation. Today I'm speaking with Dr. Keivan Stassun, Associate Professor of Astronomy at Vanderbilt University. Keivan is the first author of this exciting paper. Keivan, what did you discover?
Well, what we discovered are two very young stars in this Orion Nebula stellar nursery, and these two young stars have formed out of the same material of gas and dust in the clouds that make up the Orion Nebula, and they formed together, and so they orbit one another in what we call a binary star system. And it turns out that these two young stars that orbit one another weigh almost exactly the same. They have the same mass. And so that's why we refer to them as identical twins. We expect them to be identical in every way because they have identical masses and because they formed at the same time out of the same material.
Wow, so twins that don't look exactly alike, but yet you still call them twins. How are they different?
Well, that's right. We would expect them, perhaps naively expect them to be identical in every way, just like identical human twins. You would expect to have all of their characteristics be the same. These two stars turn out to be different in several respects. One is quite a bit hotter than the other, about 300 degrees hotter. It is also considerably brighter than its sibling, almost twice as bright. We also have early indications that it may be physically larger, have a larger diameter than its twin. So even though these two identical twins weigh the same, they have different temperatures, they have different brightnesses, and probably different diameters as well. So this was quite a surprise to us.
It does sound like an aha moment. How might your discovery affect the study of astronomy?
Well, in truth, we have not until now had a very good understanding of how twin stars are born. We have undertaken a large project to study a number of very young twin stars, and specifically twin stars that orbit one another in such a way that we periodically see them eclipse one another as they orbit. And because they eclipse one another, we're able to make direct and accurate measurements of their basic physical properties. The discovery that we've made here about the differences in properties in these identical twins, which we attribute to a difference in birth order between the two siblings in this system, will help us refine our theoretical understanding of how young stars go through the very early evolutionary process, how stars are born.
You worked with a team of scientists at several universities with funding from the National Science Foundation. Can you tell me about your process?
Well, in many ways, the support that we received from the National Science Foundation over a period of time was absolutely crucial to the work that we've been doing here. Initially, this project was started by my PhD advisor, Bob Matthew, at the University of Wisconsin, and myself when I was his student. That initial work was funded by an NSF grant to him as principal investigator. I was also supported at that time on an NSF graduate research fellowship. As the work continued over the years, National Science Foundation support remained critical in a number of ways. Certainly the funding support that we received directly as investigators, but also for providing the various ways in which we collect the data for this kind of work. Just as one example, some of the critical follow-up data that we collected at the Hobby-Eberly telescope, a very large telescope at the McDonald Observatory in Texas, we were able to collect those data because the National Science Foundation, through a cooperative agreement with the Hobby-Eberly telescope, allows astronomers like us at other institutions to have some amount of access to that facility. So that was another way in which NSF helped enable this work. Lastly, through an NSF career grant to myself, I've been able to support the involvement of a number of students, both undergraduate and graduate students, here at Vanderbilt University and also at Fisk University, our historically black university partner here in Nashville. in helping to collect the data that went into this work, and ultimately it's a training and workforce development experience for them.
A look at the Orion Nebula is vast and possibilities seem endless. What's next for you in your research?
Well, this is ongoing work. It turns out that to find a system like this one involves a long-term, painstaking search. Eclipsing binary stars, as I said before, two stars that orbit one another and periodically eclipse one another, are rare and hard to find. And so to find them, we have to collect massive amounts of data over long periods of time and then sift through this mountain of information. Here at Vanderbilt, we've started something called the Vanderbilt Initiative in Data-Intensive Astrophysics that has as its focus specifically this kind of work, large-scale collecting large amounts of data to sift through and find the needles in the haystack like this one. So this is ongoing work.
Keivan, thank you so very much for your time, for your effort, and for your exciting discovery.
It was my pleasure. Thank you for having us.